Hello students, welcome to my channel. I'm Hashim. So now I'm going to start the 9th and 10th problem on chi-square test. So far I have completed 8 problems on chi-square test. So if you are regularly watching all these problems, definitely you are in a position to attempt this problem on chi-square test. You might have understood the meaning of the term chi-square and how to solve the problem on chi-square. Different types of problems are there, association of attributes and test of goodness of fit. But before learning the problems, you must understand the meaning, the features, the formulae, the methods, all these theory. So if you have not watched, I suggest you go to the playlist of my channel, select the subject statistics for management, select the video of chi-square test theory. Be perfect, then you can start the problem. So watch the video till the end, don't skip in between and don't join in between if you want perfect knowledge. Now, before starting the 9th problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Take the screenshot of the points, then I'll explain. Come on, see the 9th problem. Following is the classification of 100 students according to their sex and height. Test whether the height of the students is dependent on the sex. The genders are male and female and the height tall and short. So this classification, so totally 100 students have been analyzed, have been researched to find out whether relationship is there between sex and height. Null hypothesis, no relationship at all. The height of the students will not depend on the sex. That means whether male or female, both are equally tall or both are equally short. There is no relationship at all. That is a null hypothesis. Alternative hypothesis, yes, there is association between sex and height. That is the test. Now, the data given in the problem is observed frequency and we have to find out expected frequency. In the last 8 problems I have explained observed frequency table, whatever is given in the problem, same thing I have written: sex, male, female, height, tall, short, total. So data given in the problem 30, 40, 20, 10. 30, 40, 20, 10. The total is 50 tall and 50 short. And males are 70, females are 30. Total persons researched 100. This is the observed frequency. Actual frequency. Now expected frequency table. Same table we will draw. We will take the totals also same. Then we apply the formula for expected frequency. The formula is row total into column total divided by grand total. What is the row total here? 70. Same totals I have copied down. Then 70 is the row total. Column total is 50. So 70 into 50 divided by grand total 100. Again I repeat, 70 into 50 divided by 100. You will get 35. Similarly, row total is 30. 30 into 50 divided by 100. You will get 15. Same way, 70 into 50 divided by 100. 35. 30 into 50 divided by 100. You will get 15. This is not given in the problem. We have calculated expected frequency. Right? How? Multiply the row total into column total divided by grand total. That's it. Now we are having observed frequency and expected frequency. We can compute the value of chi-square. That is O. Observed frequency 30, 40, 20, 10. 30, 40, 20, 10. Expected frequency 35, 35, 15, 15. 35, 35, 15, 15. Now O minus E. 30 minus 35 minus 5. 40 minus 35, 5. 20 minus 15 is 5. Then 10 minus 15 minus 5. O minus E. Now square this O minus E. 5 5 is a 25. Minus into minus will become plus. 5 5 is a 25, 25, 25. Now O minus E whole square divided by 5. So 25 divided by 35, 0.714. 25 by 35, 0.714. 25 by 15, 1.667. 25 by 15, 1.667. Total is 4.762. This 4.762 is called computed value of chi-square. Now we write down the steps. Totally 6 steps we have. In the first step, we lay down the hypothesis. That means what is null hypothesis and what is alternative hypothesis. The symbol for null hypothesis is HO. And the symbol for alternative hypothesis is H1. So HO, null hypothesis. The meaning of null is no difference. So there is no association between sex and height. That means the two variables are completely independent. No relationship at all. That is the null. Alternative hypothesis, yes, there is relationship between sex and height. The two variables are not independent but dependent. Now step 2. Level of significance. Normally, sometimes it will be given in the problem, sometimes it will not be given. If it is not given, we assume, let it be 5%. 5% means 0.05. You can take 0.01 also, 0.02 also, but normally 0.05. Degree of freedom, V is equal to C minus 1 into R minus 1, because it's a problem of association of attributes. Two attributes are given, that is height and sex. Whenever two attributes are given, the problem is of association of attributes. Here the degree of freedom is C minus 1. Column, C stands for column, R stands for rows. So 2 columns and 2 rows. So 2 minus 1, 2 minus 1. 1 into 1 is 1. So V is equal to 1. V stands for degree of freedom. Step number 4, test statistic. Here we find out what is the computed value of chi-square. Already we have calculated 4.762. Next step, step number 5, critical value. Here we have to refer the table. The chi-square table will be available in every textbook at the end of the page, or I have already provided a PDF of this chi-square test in the description. Make a copy, keep it ready. In examination you can carry this, and many a times the values will be given in the problem itself. In that case, we don't need this table. Now for 1 degree of freedom at 5% level, what is the value? Row. In row degree of freedom, in columns we are given level of significance. So 1 degree of freedom under 0.05, it is 3.841. So 3.841 is the critical value, table value. Now compare the table value and the computed value. If the computed value is greater than table value, it falls in rejection region. Here computed value is 4.752. Critical value is 3.841. So computed value is greater than critical value. So it falls in rejection region. The null hypothesis is rejected. And alternative hypothesis will be accepted. What is the alternative hypothesis? There is association between sex and height. In other words, height depends on sex. So ultimate conclusion, HO, that means null hypothesis rejected, and we conclude that there is association between sex and height. That's all. This is the procedure of solving a chi-square test problem. Now, one more problem I am going to explain you. 10th problem. 4 coins are tossed. A coin will have 2 faces, one head, one tail. When you throw the coin, you may get head up or you may get tail up. The probability of head and tail will be equal. Anything you can get, 50-50 chance. So 4 coins are tossed at a time. For how many times? 160 times. And the following results were obtained. Number of heads 0. When 4 coins are thrown, all the 4 coins are showing tail. That means 0 head, no head at all. How many times it occurred? 17 times. So out of 160 times, 17 times we get no head. That means all the 4 coins are showing tail. And 1 head. That means out of 4 coins, 1 coin is showing head up, whereas other 3 coins are showing tail. How many times it occurred? 52 times. 2 head. That means out of 4 coins, 2 coins are showing head up and 2 coins are showing tail up. This happened for 54 times. 3 head and 1 tail, 31 times. All the 4 heads, 6 times. This is the observed frequency. Experiment was done and we have noted down the results. So this is the observed frequency. Can coin be regarded as unbiased? Unbiased means genuine. Is the coin genuine? When the coin is genuine, when the probability of head and probability of tail is equal. The probability of head is 1 by 2 and the probability of tail is also 1 by 2. Then it is called unbiased coin. That we want to prove. So null hypothesis, yes, the coin is unbiased. The probability of head is 1 by 2 and the probability of tail is also 1 by 2. This is null hypothesis. Alternative hypothesis, yes, the coin is biased, not genuine. The probability of head and tail are not equal. That will take it in alternative hypothesis. So here N stands, capital N stands for number of times we are making the experiment, 160 times. Small n, how many coins we are throwing at a time? 4 coins. So small n 4, capital N 160. P, small p, probability of getting head up, and Q, probability of getting tail up. The probability of head up is 1 by 2 and the probability of tail is also 1 by 2. So according to binomial probability law, in this situation of coins, we apply binomial probability law to find out the expected frequencies. This binomial probability law, if you want in detail, separate video is there. In this statistics for management, under the chapter theoretical distribution, we have 3 distributions: binomial, Poisson and normal. All these videos already I have uploaded. You can visit the playlist, select the subject statistics for management, select the video of binomial distribution. You can get perfect knowledge about what is binomial distribution. So here, according to binomial probability law, P of R, probability of R successes is NCR, P to the power of R, Q to the power of N minus R. So here P of R is equal to small n. How much is small n here? 4. CR. R stands for how many times heads we are getting. Number of times head is R. So in place of R, we have to substitute 0, 1, 2, 3, 4. We have to find out P of 0, P of 1, P of 2, P of 3, P of 4. 4CR, P. How much is P? 1 by 2. Q is 1 by 2. To the power of R to the power of N minus R, 4 minus R. This is the formula for probability of R according to binomial. Now expected frequency. We don't require only probability, we require expected frequency. So whatever probability we get, that will be multiplied by capital N. So N into P of R, you will get expected frequency. N is 160. 160 into P of R. Now expected frequency, how to find out? First one, number of heads. Number of heads are 0, 1, 2, 3, 4. And expected frequency. Capital N is 160, I am writing 160. Then P of R is NCR, N is 4 and R is 0. N is 4, R is 1. So in place of N we are writing 4, R 0, 1, 2, 3, 4. So now half to the power of 0, half to the power of 4 minus 0. Substituting in this formula. Right? Similarly 160 into 4C1, half to the power of 1, half to the power of 4 minus 1. So already 160 is there. We need to find out 4C0, 4C1, 4C2. In mathematics there is a formula of combination. NCR. NCR, here I have written NCR is equal to N factorial divided by R factorial into N minus R factorial. This is the formula for NCR. We need 4C0, 4 factorial divided by 0 factorial into 4 minus 0 factorial. 0 factorial means 1. Always remember. 0 factorial 1. 4 minus 0 is 4 factorial. So numerator 4 factorial, denominator 4 factorial, cancelled 1. So we got 4c0 is equal to 1. Similarly 4c1. So 4 factorial by 1 factorial into 4 minus 1 factorial. 4 minus 1 denominator means 3. Actually, what do you mean by 4 factorial? 4 into 3 into 2 into 1. 5 factorial, 5 into 4 into 3 into 2 into 1. That is called factorial. So denominator we have 3 factorial. Numerator also will stop at 3 factorial. 4 into 3 factorial. So this 3 factorial get cancelled. So 4. So 4c1 is equal to 4. 4c2. 4 factorial divided by 2 factorial into 4 minus 2. 2 factorial means 2 into 1. And 4 minus 2 is 2 factorial, 2 into 1. And 4 factorial, 4 into 3 into 2 into 1. Now this 2 gets cancelled. 2 2s are 4, 2 3s are 6. So 4c2 is 6. 4c3. 4 factorial by 3 factorial into 4 minus 3 factorial. So denominator we have 3 factorial. So numerator also will stop at 3 factorial. 4 into 3 factorial. This 3 factorial will get cancelled, remain 4. And remember 1 factorial is nothing but 1 only. Then 4c4. 4 factorial by 4 factorial into 4 minus 4 factorial. 4 minus 4 means 0. 0 factorial is 1. So numerator 4 factorial, denominator 4 factorial, cancelled. So 1. So we got all these 4c0, 4c1, 4c2, 4c3, 4c4. All the values we got. Now here, half to the power of 0, half to the power of 4. In mathematics, there is a principle. When bases are same, powers can be added. Bases are same. 1 by 2, 1 by 2. Power 0 plus 4 is 4. 1 plus 3 is 4. 2 plus 2, 4. 3 plus 1, 4. 4 plus 0, 4. In all these cases, you can see half to the power of 4. So only once we calculate. 1 by 2 to the power of 4, 0.5 to the power of 4, which is 0.0625. Now we can find out expected frequency. 160 in 14641. Here we have calculated 14641. Then we have taken half to the power of 4, 0.0625. Multiply all these terms, you get 10, 40, 60, 40, 10. What is this? Expected frequencies. So we are having observed frequencies which are given in the problem. 17, 52, 54, 31 and 6. 17, 52, 54, 31 and 6. These are the observed frequency. And these are the expected frequency just now we got. The total of expected frequency should be same, 160. Now O minus E, 17 minus 10, 7. 52 minus 40, 12. 54 minus 60, minus 6. 31 minus 40, minus 9. 6 minus 10, minus 4. O minus E. Square it. 7 sevens are 49. 12 into 12, 144. 6 6 are 36. 9 9s are 81. 4 4s are 60. Now O minus E whole square divided by E, expected frequency. 49 divided by 10, 4.9. 144 divided by 40, 3.6. 36 by 60, 0.6. 81 by 40, 2.025. 16 divided by 10, 1.6. Take the total, 12.725. This is the computed value of chi-square. Now we have to apply the 6 steps to give the conclusion whether the coins are unbiased or biased. So null hypothesis HO. The coins are unbiased. That means the coins are genuine. The probability of head and tail are equal, 50-50. That is null. Alternative hypothesis, no. The coin is biased. That means not genuine. The probability of head and tail is not equal. That is alternative hypothesis. Step 3, level of significance. It is not given in the problem, that's why we have assumed 0.05, 5%. Then degree of freedom, V is equal to N minus 1. Remember the formula for degree of freedom will change. When we test association of attribute, it is C minus 1 into R minus 1. Here it is not association of attributes. It is test of goodness of fit. Here the formula is n minus 1. N means number of pairs. How many pairs we have? 5 pairs. 1, 2, 3, 4, 5. So 5 minus 1 is equal to 4. V is equal to 4. Next step, test statistic. The computed value of chi-square already we have calculated 12.725. Then the critical value, step 5. Refer the table and find out what is the value of chi-square. It is not given in the problem. That's why we have to refer the table. The PDF of this table already given in the description. Here, V is equal to 4. So 4. In the row 4, under 0.05, you will get 9.488. So 9.488 is the table value of chi-square. Finally, we have to give the decision. Compare the computed value with the critical value. If the computed value is less, accept the null. If the computed value is greater, reject the null. That is a simple case. Now here 12.725 is the computed value. Critical value is 9.488. So computed value is greater than the critical value. So it falls in rejection region. Null hypothesis is rejected. This null hypothesis I am rejecting. This null is rejected. That means alternative is accepted. What is the alternative? The coins are biased, not genuine. That means the probability of head and tail are not equal. That's it. So 2 problems I have explained. So totally 10 problems so far I have explained. So if you want perfect knowledge, watch all the videos from beginning till end and practice yourself these problems. Then only you will get the full command. Otherwise, simply by watching 1 or 2 videos, you will just get the technique, but you will not go to the logic of the problem. I have explained each and every point to the best of my ability. So if you are satisfied, give a like to the video. Share my channel among your friends, among your groups, so that more students can watch the video and enhance the knowledge and get excellent results in their exams. So don't forget to subscribe my channel. Come forward and subscribe my channel. Inshallah, we'll continue the next problem in the next video.